Okay. Let's take a look at this first one. We got 3x plus 1 over x minus 2 plus 4 over x equals negative 8 over x squared minus 2x. Now this is a rational equation. The first thing we do is factor all our denominators. Can't do anything with x minus 2. Can't do anything with x. But this last fraction I can factor out a GCF, which is x. And that gives us x minus 2. Now we're going to multiply everything by the LCM of all our denominators. Now I take my first factor, let's say the single x. I'm looking for the greatest number of single x's in a single denominator. None here, 1 here, 1 here, so I'd have 1. Then I go to my next factor, which is x minus 2, and I'm looking for the greatest number of x minus 2's in a single denominator, which is 1 here, none here, 1 here, so I'd have 1. And this is our LCM, so that's what we multiply everything by. So multiply times each fraction. This x minus 2 cancels that x minus 2. This x cancels this x. This x cancels this x. This x minus 2 cancels that x minus 2. So I'm left with x times 3x, which is 3x squared, x times 1, which is x, plus 4 times x, which is 4x, 4 times negative 2, which is negative 8. And over here is a negative 8. So I got 3x squared plus x plus 4x is 5x. Notice how there's a negative 8 on both sides, so those cancel. Now I want to factor, so I'll factor out an x. And that gives us 3x plus 5 equals 0. Zero factor property says you get 0 on one side, you factor the other side, you set each factor equal to 0. So I'll set x equal to 0, and I'll set 3x plus 5 equal to 0. This is maybe our answer. We'll come back to that. And here I'll take 5 over, becomes a negative 5, divide both sides by 3, and we get negative 5/3. Now I said maybe it's your answer, because you have to semi-check these. You need to plug these back in, the original problem, make sure none of them cause the denominator equals 0. Now, the negative 5/3 is fine. But at the 0 here, if I plug that back in, if I put 0 in for x right here, I'll have 4 over 0. So our only answer is negative 5/3. Let me just double check my work. Let's see, 5x. Yep, okay. Let me clear that off. And we have, I won't do this one, same way you factor your denominators. This would factor as t plus 1 times t plus 2. And then you'd multiply everything by your LCM, which would be t plus 1, t plus 2. I'd have to know what the directions are here. If it's to simplify, I don't see 7 to the third. You could do 7 to the third, but wouldn't cancel with anything up here. So I don't know, I need to see the directions on that. This one I'm assuming is solve. So I got x minus 4 over x minus 5. And what I'm going to do is I'm going to bring this fraction and move it to the left side. So we got minus x plus 5 over x plus 7. Greater than or equal to 0. Now I need to get a common denominator. My common denominator would be x minus 5 times x plus 7. Now what you multiply by the bottom, you have to multiply by the top. So here I'll multiply the top part by x plus 7 also. Now over here, I multiplied the bottom part by x minus 5, so I can multiply the top part by x minus 5. So this is going to give us x squared plus 3x minus 28 over our denominator. This one's x squared minus 25 over our denominator. Now that they have the same denominator, we can merge together the top parts. Whenever you have a minus in front of your fraction, this flips the sign of everything on top. So it's going to flip the sign of the x squared and of the negative 25. So I'm going to have x squared plus 3x minus 28 minus x squared plus 25 over x minus 5 times x plus 7. X squared minus x squared drops away. I got a 3x. Negative 28 plus 25 is negative 3 over x minus 5, x plus 7. Now I notice I can factor a 3 out of the top. And that gives us x minus 1. I do that to see if anything can cancel, but it won't. Now I need to find my critical values. What I do is I set the x minus 1 equal to 0, x minus 5 equal to 0, and x plus 7 equal to 0, which gives us 1, 5, and negative 7. Now we start off negative infinity goes to our smallest one. Our next one is 1. Our next one's 5, and then clear over here is positive infinity. And we want to pick test cases. Something between negative infinity and negative 7, like negative 8. Something between negative 7 and 1, like 0. Something between 1 and 5, like 2. Something greater than 5, like 6. And we want to plug these into our inequality and see which ones are true. For example, if I plugged in negative 8, I'm going to have 3 negative 8 minus 1 over negative 8 minus 5 and negative 8 plus 7. And we're wondering if that's greater than or equal to 0. Negative 8, negative 1 is negative 9, times 3 is negative 27. Negative 8, negative 5 is negative 13. Negative 8 plus 7 is negative 1. Now, negative 13 times negative 1 is a positive 13, and negative divided by positive negative. Negative is not greater than or equal to 0, so this is false. So this interval is not part of our answer. So you go through, and that's how you figure out what your answer is. Test cases that work. Okay, let me clear that off. And this is the cube root of x plus 4 equals 5. Now this is a radical equation. With a radical equation, you get the radical by itself one side, nothing in front of it, nothing after it. And then you raise both sides to a power equal to the index. Index is numbered in a slot, so we'll raise both sides to the third power. Now when your index matches a power, they cancel each other. So you got x plus 4 equals 125. Take the 4 over, and you get x equal 121. Now you'd want to take this and plug that back into your original problems to make sure it checks. You always want to do that with radical equations. Now here we got x to the 2/9 equals 4. Whenever you got a rational exponent of fractional power, you get to power with the fractional power by itself on one side, nothing in front of it, nothing after it. Then you raise both sides to a power equal to the reciprocal of it. So we'll take both sides of 9/2 power. Now, if you got an even number on top, before you raise both sides to a power, an even number means you put a plus or minus on the other side. If this was an odd number up here, like 1, you would not put the plus or minus. Now, 4 to the 9/2, and plug that in my calculator. 4 caret, beginning parentheses, 9 divided by 2. gives us 512. 2's cancel here, 9's cancel here, just leaves me x. And those would be my two answers. Clear that off. And another one is square root of x minus square root of x minus 7 equals 1. Now I raise, or I have to get an radical by itself, so I take that negative over. Raise both sides to power equal to the index, so I'll square both sides. Now, square root and the second power cancel each other, so that gives me x. And over here, I'll rewrite this as 1 plus the square root of x minus 7 times 1 plus the square root of x minus 7. And I'm going to FOIL that. So I take 1 times 1, which is 1. 1 times square root of x minus 7, which is square root of x minus 7. Square root of x minus 7 times 1, which is square root of x minus 7. And square root of x minus 7 times square root of x minus 7, which is x minus 7. Okay, here's my x. Combine numbers. 1 minus 7 is negative 6. And combine these two radicals together, and that gives me 2 square root of x minus 7. Now notice I have an x on both sides, so that's going to drop away. So you got 0 is equal to negative 6 plus 2 square root of x minus 7. Now we still need to get the radical by itself, so I take negative 6 over. Then divide both sides by 2. And now we're going to raise both sides to the second power again. Three squared is 9, and this gives me x minus 7. Take the negative 7 over, and you get x is equal to 16. Now we have to check this, though. If I put 16 back up here, square root of 16 is 4. Minus 16 minus 7 is 9. Square root of 9 is 3. And 4 minus 3 does give you 1. So that'd be our answer.